In this video, we are going to learn about Newton's third law. All of you know Newton's third law, right? The easiest of all laws. Every action has got equal and opposite reaction. Let me ask you a simple question. You know that the earth is going around the sun. This is the sun and this is earth. Right? Why is the earth going around the sun? The sun is pulling the earth. Right? Why doesn't it go straight towards the sun? Because the earth picks some tangential velocity when it was getting formed. So earth falls towards the sun but does not go into the sun because this velocity carries it forward. And the earth goes around the sun in an elliptical orbit. Right? Now, sun is pulling the earth. Is the earth pulling the sun? Yes, it is pulling. Whose force is more? You may be tempted to say sun's force is more because the field sun is more massive, so it must be pulling with greater force. Earth is less massive, so it must be pulling with lesser force. But that is wrong because every action has got equal and opposite reaction. With whatever force the sun pulls the earth pulls the sun with an equal and opposite force. Please understand that. This is the earth, say, and this is an apple. Okay, if you don't like apples, you can draw mangoes. So this apple, if I leave it, what will happen? It will fall towards the earth. Why? Because the earth is pulling it with some force. Is the apple pulling the earth? No, actually it is pulling. So earth is pulling the apple. Apple is pulling the earth. Both with an equal and opposite force. This is Newton's third law. Very easy to memorize. Very difficult to understand. These two forces are equal and opposite. Then you may ask, if you drop the apple falls to the earth. Does the earth fall towards the apple? Again the answer is yes. Because acceleration of apple will be this force by mass of apple, Newton's second law. And that will come out to be g, 9.8 meter per second squared. The acceleration of the earth will not be zero. It will be that same force by mass of earth. And this will come out to be 10 to the power minus 25 meter per second squared. You may think, how is that possible? It must be true for Newton's third law to be correct. Every action has got equal and opposite reaction. If I push this pen, does the pen push me back? Yes. With what force? Equal and opposite force. Then how does the pen accelerate forward? Do these forces not cancel each other? Suppose a horse is tied to a cart and you tell the horse to move forward. Horse is educated, knows physics, knows English. So, horse tells you, if I pull the cart will pull me back with an equal and opposite force. So therefore, the cart will not move. Is the horse right or wrong? Horse is wrong because he can pull the cart. Then how do we reconcile this with Newton's third law? The pull of the horse acts on the cart. The pull of the cart acts on the horse. Action and reaction are equal and opposite, but they act on different bodies and never cancel each other. This is very important to understand. People memorize every action has got equal opposite reaction. But how does it translate to real life? That you must understand. First thing, every action will have an equal and opposite reaction. Second thing, action and reaction always will act on different bodies and never cancel each other. Let's try to understand one more situation. This is a table. A mass M is resting on this table. So now let's try to understand what are the forces acting on this mass. First thing, weight will act vertically downwards, mg. The table will exert a normal force on the mass, N. If no other force is there, normal will be equal to mg because there is no acceleration vertically, horizontally also there is no acceleration, but we are more interested now in vertical acceleration. So N is equal to mg. Now, are these forces, normal reaction and mg, action reaction forces as defined by Newton's third law? Answer is no. Then where is the action reaction pair for this mg? Start thinking. This mg and n are not action reaction pair because they are acting on same body, right? And they are different kind of forces. Mg is because of gravitational force. Normal reaction will be actually at the molecular level and electromagnetic force. So where is the action reaction pair of this? Please understand that this mg is because of the earth. If the earth were not there, there would have been no mg, no force like that. So now the earth is pulling this mass with a force mg. So the block is pulling back the earth with a force mg. And these two are action reaction pair as defined by Newton's third law. Action reaction pair are always same kind of forces. If action is gravitational force, reaction also will be gravitational force. Now where is the action reaction pair for this N? Actually there is one more N acting on the table, and that N is the action reaction pair for this normal reaction. So please understand that Newton's third law is very easy to memorize. Action and reaction are equal and opposite. Very easy. And they act on different bodies. But important thing to remember is that they never cancel each other. Action, reaction will never cancel each other. So very easy to memorize, very difficult to understand. So please remember, Newton's third law is very easy to memorize, but very difficult to understand. So understand it well, okay? This is Newton's third law. A very easy law, very difficult to understand.